Okay, today we want to incorporate the trigonometry. I know that that's what you're wondering. Yesterday you're like, Mr. Gens, why is this part of the trigonometry unit? It doesn't seem like trigonometry. It seems like we're just talking about graphing things differently. And so here's the piece that we need to consider. So you have this xy coordinate here. And you notice that anytime you plot an xy coordinate, you can form a triangle. And it doesn't take long to look at it and see that we have an r value and we have a theta value. Everybody okay with that? Does that look familiar? Yeah. Can somebody give me an equation that expresses a relationship between x, y, and r? Yes, x squared plus y squared is r squared. Everybody agreed? Or in other words, r is equal to the square root of x squared plus y squared. This is the third time in a row that you've seen that. We saw it with complex numbers. We saw it with vectors. You see it again with polar. Can somebody give me a trigonometric equation that relates x, y, and theta? Starts with t, rhymes with angent. Tangent of theta equals y over x. Right? Just like tangent of theta is b over a. We're just switching up the letters. That's if you want to go from rectangular to polar. So if you're given an xy coordinate, you just take the square root of x squared plus y squared. That gives you r. If you want to find theta, just solve tangent theta is equal to y over x. This we've done before. Let's go ahead and do it again. It says, let's do example 3. We'll kind of switch around here. It says, find the polar coordinates of 3, negative 3. 3, negative 3. That means I need to take this xy and I need to turn it into r theta. So r is equal to the square root of what? X squared plus y squared, which would be 9 plus 9, or the square root of 18, which is 3 roots of dos, which is Spanish for 2. I solved tangent of theta is equal to what over what? What is negative 3 over 3? Negative 1. Oh, tangent negative. In which quadrants is tangent negative? Second and fourth. If I inverse 1 on my calculator, what do I get for tangent? 45 degrees. Can somebody tell me, am I looking for the angle in the second quadrant or the fourth quadrant? The fourth quadrant. So what will my angle be? 315 degrees. Convert 315 degrees into radians. 7 pi over 4. So we have 3 roots of 2, comma, 7 pi over 4. That is the polar form. Next one, again, find the polar coordinates of negative 5 roots of 3, 5. R is equal to square root of, this is what I yelled at you yesterday regarding your chest for. If we square negative 3 or negative 5 roots of 3, what do you get when you square negative 5? 25. Times, what do you get if you square the root of 3? 3. What do you get if you square 5? So in other words, you get 75 plus 25 is equal to the root of 100, which is 10. We need to start getting those right all the time. Right now, we're only about 75% as a class. We want to get 100% of those right. Okay? We can do it. I'm confident. Now I set up tangent of, excuse me, tangent of theta, excuse me, smoker's cough. Tangent theta is equal to what over what? Those cancel, and I get -1 over the root of 3. Some of you decided to just get rid of the 1 altogether, and you just wrote -√3 on the test. That's totally illegal. Okay, broke a lot of rules there. So it is just -1 over the root of 3. Again, where is tangent negative? Second and fourth. Do you know what you get if I inverse 1 over the root of 3 on the calculator? I like to hand out my own notes. All right, what do I get if I inverse the root of -1 over the root of 3 on my calculator? Okay, well, you can have a negative, but suppose we leave the negative off. What do you get if you inverse 1 over the root of 3 on your calculator for tangent?
60. I don't know. 45, 60.
So if you do 3, the root of 3, then you get, what mode? Let's go back to degrees. So if you do the root of 3, that's when you get 60. If you do tangent inverse of 1 divided by the root of 3, that's when you get 30. Yes, we applaud your efforts. Yes? Is this my final answer?
No.
So what's no problem there. If you would like to rationalize that, go ahead. I promise you will get the same result. You'll get 30. But it's not my final answer, so we don't really care. Okay, so which quadrant am I working in? Second quadrant. Because if you were to graph -5 roots of 3, 5, it would place you right over here. And so what is that angle then? 150 degrees. 150 degrees, turn it into radians. 5 pi over 6. So my coordinate is 10, comma, 5 pi over 6. These are the polar forms of those rectangular coordinates. So, what have we learned so far? Number one, how to graph polar coordinates. We learned that yesterday. How to rename them. Second of all, you should be able to take rectangular coordinates and put them into polar form. You already have this skill, don't you? Yep. You should have had it from last unit and the one before that as well. So let's go to the other piece. Let's convert polar to rectangular. Polar to rectangular. Meaning we want to know how to determine x, and we want to know how to determine y. So given r and theta, how do you determine x and how do you determine y? This is something you already know how to do. Look at these pieces and tell me the association between x, r, and theta. Cosine, right? Everybody, cosine? Cosine of theta is equal to x over r. So if I just multiply both sides by r, I get x is equal to r cosine of theta. Piece of cake, upside down. And then if you look at r, y, and theta, that's going to be my sine value. Sine of theta is equal to y divided by r. Multiply both sides by r, y is r sine of theta. So if you want to go from polar to rectangular, if you want to figure out the x, y value, simply use those formulas. So let's execute that. Convert 2 pi over 3 to rectangular form. Or in other words, we have r and theta, and we are going to come up with x and y. So x is equal to 4 times what? We just wrote it up there. Cosine of, which is 2 pi over 3. Y is going to be That's all it is. Now we just have to come up with the exact value. 2 pi over 3. How many degrees is 2 pi over 3? 120 degrees. That leaves me with a 60-degree angle. What is that terminal point sitting up there? Negative 1/2 root of 3 over 2. Okay. So for x, is cosine the x value or the y value? X. So you have 4 times negative 1/2. What's 4 times negative 1/2? Negative 2. And then we have 4 times the sine of 2 pi over 3. That guy right there, we have the root of 3 over 2, which is going to be 2 roots of 3. So my xy coordinate is negative 2, 2 roots of 3. See what I'm saying? Now, some people, when they do this, if you want a reasonable way to check your answer, again, I would just encourage you. It says negative 2, 2 roots of 3. So if you were to plot that, you would go back 2, and then 2 roots of 3. The root of 3 is like 1.7, so it'd be up 3.4. 1, 2, 3, 4. So back 2 and up 3.4. So I'd be right there. Okay. So you tell me. Does that look like it has an angle? That spot right there, does it look like it has an angle of 2 pi over 3 or 120 degrees? It does. Does it look like it could be about 4 units from the center? Yeah, this is 4 right here. Looks like it, yeah, it works out pretty well. So you can check and verify your answers to some degree by plotting them and see if they look like they would be about the same. You try the next one on your own. Go. Root of 2, root of 2. So we take negative 2 and we multiply it by that guy. You know that the exact value of cosine of 5 pi over 4. Oh, it's still on. There you go. Yeah, the exact value of cosine of 5 pi over 4 is in fact negative root of 2 over 2. And sine as well as negative root of 2 over 2. So you get root of 2, root of 2. Now that's interesting because if you would go back and plot this right here, I would take that guy and plot it. Notice you get 5 pi over 4, which is going to bring you to about right there, isn't it? But then the negative 2, because the radius is negative, what do? I go in the opposite direction. So which quadrant do I end up in? The first quadrant. So does that look like it could end up being the root of 2, root of 2? Sure does. Notice that it's a little bit misleading because it's got a negative there and then my final answer doesn't. But that's what happens in that situation. Good. I would like to save this last bit for tomorrow, so we'll spend 3 days on polar. We'll probably spend 2 days on parametric, which would place us to taking the test next week, either Wednesday or Thursday. So we'll see kind of where we get. But we will stop there for now. We'll get to these pieces tomorrow. Just please look at your worksheet so you can understand the problems that you will now attempt to do. Huh. There you go, Mr. Gantz. You should act like you know what you're doing today. Okay, so find the rectangular coordinates for the points whose polar coordinates are given. Can you now do that? You can. Convert the following rectangular coordinates to polar coordinates. Can you now do that? Yes, you can. This last one here is the piece that we'll go over tomorrow. Everybody okay? Smaller bites, huh? Enjoy it while it lasts.